Welcome back. Now, second method of designing a combination circuit, the corresponding concurrent code is through when statement. And in VHDL, when basically appears in two forms. One is the simple when, which is simple when and else statement. And second we call a selected when, which is with, select, and when. Fine. So let's start the first one, the simple when. So it has a simple syntax. So this is the first one. The syntax is that you will have some assignment, and corresponding to that assignment you will have to mention the condition using when. Fine. Then if there are multiple conditions you will use else, then give second assignment and the condition for this assignment, again using when. And likewise it can continue jitni aapki conditions होंगे. We'll take an example. Fine. This is the case of simple when. Fine. Then in case of selected when, you basically have an identifier. तो उसमें वो use with, then define the identifier जो आपने declare किया है, तो उस identifier पे फिर conditions लगेंगी. Select, then you give some assignment, when, then a particular value of that identifier. Similarly, if you have another condition, assignment, when, and what is the value of identifier for this particular assignment. Okay, so an important thing here is that you have this identifier, whereas यहाँ पे identifier नहीं है. So I think this is not semicolon, this is comma, like this. Okay, and we'll use both these statements in designing this multiplexer. We'll keep the top level design same. यही description होगा A, B, C, D. These are my selection lines S1, S0. The output is Y. So this portion remains the same, library declaration and entity. But this architecture we will change. Earlier we did it using operators. Now we will try to code it using first this and then maybe later using the with select. Okay, so I will directly write the architecture. So architecture behavior of mux is, right? Then we will begin. Now the format is give some assignment, then using when come up with a condition. Okay, and if there are multiple conditions you can use else. So this case may to be something like this, that y is equivalent to a. Just have a look at this top level circuit. Y is equivalent to a when s is equivalent to 0 0. Okay, so same thing, I will write y is equal to a. This is my assignment. Then when s is equivalent to 0 0. ठीक है, अब चूंकि और भी कंडीशंस है, 0 1 पे कुछ और है, 1 0 पे कुछ और है, so we will continue with else b when s is equivalent to 0 1. Then again else c when s is equivalent to 1 1. Else you can simply put d. Okay, so this is how we write it using when statement. Then you will end your architecture. This is the use of simple when. Fine. Then we can again, okay, ये तो हो गया simple when. Second is selected when. So let's try again. I will write only the architecture library or जो आपका entity है, it remains the same. So architecture behavior of mux is, then I will again begin. Fine. So this time we have to use with select. So I will use with. I have to define some identifier जिस पे condition लगेगी. So obviously in this case s is my identifier. Then select. उसके बाद assignment y is equivalent to a when, क्योंकि आपने s select किया है, so you don't have to mention it in the when. You just mention the condition on the s when 0 0. Put a comma. B when 0 1. Put a comma. C when 1 0. And D when others means इसके बगैर जो भी combination है. This is again a kind of an attribute in VHDL. We often use it. Right? Then we will end our architecture. ठीक है. So दोनों side by side है. You can always compare the two. Fine. So this is the use of when else statement and its selected form with selected when. Fine. So it actually depends upon what kind of circuit you have to code. Sometimes it is easy to use operators. Sometimes it is easy to use this what you call when statement, and in some cases it is easy to use the with selected when statement. Right? So let's do one more example. Let's try to design this thing. Let's say we have an 8x3 encoder. Again, it's a combinational circuit जिसमें आपका input 8 bit का है, so it will be 7 down to 0, और आपका output it is encoded, so it will be 3 bit का है तो 2 down to 0. ठीक है. And इसका जो behavior है actually जो हमें code करना है, so in this encoder this is basically an encoder where let's suppose one let me define it like this, where one and only one input bit is high at a given instant of time. Fine. And उस bit का address must be encoded. So let me just complete whose address must be encoded at the output. ठीक है. So it is something like this. अगर 8 bit का है, so if your input is like this, fine. तो क्योंकि आपका 0th bit high है तो output पे आना चाहिए 0 0 0. Similarly, if you have something like this, if I choose haphazardly like this, तो यहाँ पे आपका 0 1 2 3 4 5th bit high है. Fine. तो इस केस में जो आपका आउटपुट आना चाहिए, it should be what is the binary equivalent of 1 0 1. Okay. Similarly, if it is something like this, means आपका 7th bit high है, so you should get an output of 1 1 1. Okay. So it's a kind of an encoder where input में आपके 8 bits है, at a given instant of time only one of the 8 bits will be high, and output should be basically the binary equivalent of the position of the bit that is high. ठीक है. इसमें भी we will have library declaration. You will define library IEEE, then you will define the three packages. I will show from the entity part, although entity is also pretty straightforward. So entity, let's call it say encoder is. Then we will define our ports. X is in std logic vector. Seven down to 0. Okay. इसी तरह आपका y, it is out again in std logic vector 2 down to 0. Fine. And entity. Now after this we have to decide which approach we will use. क्योंकि यहाँ पे आपका इनपुट वेक्टर है और आउटपुट भी वेक्टर है. It will be very difficult to formulate a boolean expression for this. It's not impossible कि नहीं हो सकता है, since it is a logical thing. Definitely there will be a boolean expression, but it will be very complicated. You will have three separate boolean functions for the three output bits. So y2 के लिए you will have a separate boolean function, y1 के लिए it will be a separate boolean function, y0 के लिए it will be a separate boolean function, and the boolean function will be a function of 8 bits of your input. ठीक है, so इसीलिए मैंने इससे पहले कहा कि it basically depends upon the kind of functionality you are trying to encode. आपके किस functionality का hardware बनाना है. So sometimes operator approach is easy, sometimes the when else select with select else is when is easy. Okay? So in this case operators it will be very complex, बहुत complex हो जाएगा. तो so we will rely on the when statement. Okay? So we will have architecture, behavior of encoder is. Then we will begin and we'll go on writing the simple statements that y is equivalent to 0 0 0 when x is equivalent to 0 0 this. Okay. Then else 0 0 1 when x is equivalent to else 0 1 0 when x is equivalent to 0 0 0 0 1 0 0. इसी तरह आप सारे कंडीशंस देंगे और जो लास्ट का कंडीशन होगा आपका इट विल बी 1 1 1 when x is equivalent to this thing. Actually although from VHDL perspective you can just stop here, लेकिन अक्सर सॉफ्टवेयर्स में थोड़ा प्रॉब्लम हो जाता है. सो वही क्योंकि इसके अलावा भी बहुत सारी कंडीशंस बनेंगी. ठीक है, सो वी आर डिफाइनिंग आवर आउटपुट्स फॉर दीज 8 कंडीशंस, but we can have some other combinations क्योंकि 8 बिट्स है तो there will be 2 raised power 8 combinations, so we have to specify that. so उसके लिए we simply say कि else कि अगर इन 8 के बगैर और कोई combination आ जाए इनपुट पे, so the circuit should go into the high impedance state ZZZ like this. Okay, so this kind of completes all the permutations of these inputs. Then we will end our architecture. Right? So this is just another example. We'll stop here.